Hey there, Tianan.
Hello.
We have an agenda-free meeting today.
Getting my hour back.
Might be able to get 2 weeks straight of that because next week I probably won't be here. So welcome, Derek and Ram. I was just telling Tianan we don't have an agenda this week, so if there's anything you want to talk about, it is open hour, or we all call it early, one way or the other.
I need to review what did we even discuss last week since I've only been joining every other week. Anything I missed?
Let's see. We were chatting about the options for the layer types last week and options for parallel blob uploads.
Okay.
There's some interest on that.
And Blake 3. I don't know what's going on with that.
All right. So
Adding that to the as a digest.
Yeah.
Do we even have any runtime or registry support for Blake 3 today?
Short answer, no. But folks are interested mainly because of the large image problem. So the AI model community or large VM images and things like that, they want to build images quick. Blake 3 seems to be an answer.
What does Blake 3 have that makes that much faster? I'm not familiar with it too much, so.
So the SHA families are chained, right? The hashing algorithm is a chained algorithm, whereas in Blake 3 it's a Merkle-Dag kind of algorithm. So there's a massive amount of parallelization possible in Blake 3. So I think that's the fundamental difference.
Gotcha. Yeah.
And the PR that's linked there, we're not saying people have to use it. We're just listing it as if you see this prefix there for the digest algorithm, we're registering it. We're saying this is the Blake 3 implementation we're referring to. And
If
it
it's a
is,
different implementation, will it produce a different hash?
so Blake 3, there are multiple key sizes, I think. And so we're saying it is exactly 256 bits
Gotcha.
in the hash size. And so we're specifying exactly what it should look like. It is in the Go Digest implementation. It hadn't been, they haven't done a 1.0 or 1.1 release in ever. But at least the main branch over there does have this in the Go Digest implementation. But like I say, we're not saying that Containerd or anybody else has to support it. We're just saying if you see it, this is what it's referring to.
Yeah. I should look some into it as well. Tana, when you say it's the Merkle deck, how does the how does it do a partial verification if you only have partial content?
It probably has to be a specific size of partial content, but the hash is made up of essentially partial hashes. It's a Merkle tree of hashes.
What is the output size for that then?
Arbitrarily extensible or 256 bits.
Gotcha. Yeah, because I mean, yeah, the reason I asked that is because yeah, we've been talking a lot with the AeroFS stuff is about how we'd want to add DM Verity support, and with if you were to expose something like DM Verity, you get something, you get some of those similar properties. But the thing is, to do any sort of partial verification, you still need the full list of hashes, which is whatever ratio. I mean, the size of it's going to be large. It's going to be a ratio from the full size of the image. So if you have like a page size of whatever versus the output size, or I think if you have like a page size, like a normal page size of like 4K, you end up with like a fixed ratio of how large the DM Verity data is going to be. But that actually gives you the ability to pull stuff on an individual block or upload stuff in an individual block and verify it. I'm curious how like Blake would, I understand how Blake could give us the ability to do out of order calculations, but I'm curious how it would give us partial verification.
Yeah, I'm not actually sure about that. I haven't used it, just read about it.
Yeah, so I just know it's expensive. Like with DM Verity, it's like, I forget it, but say it's like 5% of the file size or something. Depending on how big your block size is. But yeah, there's a big cost to that because you have to have the rolling hash for, or the hash for every single block, but then you can roll it up in a single digest in the end, which could just be the SHA-256. So it's a completely, it completely changes what the hash means, but it could be the same algorithm. So what I'm trying to say is, like, you could have SHA-256 and just a completely different way of verifying, or completely different way of arriving at that SHA-256. Like if I have a SHA-256 and it's DM Verity hash, then that's a root hash from a large blob that's calculated by rolling up the hashes. Whereas normally just a chained hash of the entire content, which I think we can all agree is not good for large files, and we need to figure something else out there. But yeah, maybe the answer could be somewhere in between, because I think we might want DM Verity, but we don't expect registries to necessarily do anything from it, but this might be something we want on the runtime side. Whereas if Blake actually gives us what we want for doing large file uploads, or verifying large file uploads, that could be an easy or a nice shift as well.
Yeah, I feel like you just described the entire thing I was putting over in the upload of large artifacts. Sai, go ahead.
Yes. So I have been following the issue that I had raised, following your comments, Brandon. One thing for large uploads that we're missing is more from a registry side, not from a client side. And I put it in the last comment is, as a registry operator, we tend to like smaller files or smaller blobs, mostly because it's easy to distribute via CDNs. There's a bunch of CDNs which have limits on how big of a file they can support, and the limits are anywhere from like 5 gigs to 30 gigs. So uploading like 100 gig file basically pushes or pierces through the CDN barrier. So we're gonna end up paying a lot of money for doing direct origin traffic.
So I'm trying to wrap my head around what the actual proposal is, because we've said that we don't want to chunk the blob up in the manifest, because if we do that, bad things happen for implementations that have to reassemble everything. But we must have it chunked up for the CDN, because otherwise the CDN can't distribute it.
Yeah, I mean, yes. Ideally, if we could store the blob itself as chunked in the registry, and then have the reassembly happen at client side, that would be the best from like a distribution perspective.
Is that different from chunking in the manifest then?
It's very similar to what Derek's proposing, right? Like with the DM Verity kind of format.
Because the suggestion I was putting for chunking in the manifest, just to make sure it's kind of recaptured here, is that we just make a new media type that just says something, something, whatever AI vendor dot chunked. Put an annotation in there that may capture, here's the fully reassembled hash, so that you've got something you can look at and also validate when you reassemble it all. But if you have multiple of these multi-chunk things, you can also differentiate, okay, this was one set of chunks, this is another set of chunks. And then it just all turns into client side. The client separates into multiple chunks, the client reassembles multiple chunks. We wouldn't have any change at all to do to registries. It would be transparent to them.
Talk about the
Yes.
manifest chunking approach.
Yeah, just put it as multiple layers inside of one manifest, because I think we kind of changed topics here a little bit, because Blake 3 is there. And the one question I'll throw in the Blake 3 before we move off of that, Rom, you probably have a green checkbox there to hit merge if you wanted to. Just saying.
Oh, I can merge it?
There's probably a green box there with tempting you, and nobody's going to stop you if you pressed it. Just saying. You've got 2 approvals on the PR. So while Rom is frantically going over there hitting merge, the other PR is 573 that I think Saeed is jumping server to. And so yeah, with that.
Sorry, I joined late. I thought we were discussing that.
No worries.
Same topic.
Overlapping
just, yeah.
topics. And Derek had missed this one last week, so I figured it's good for us to bring it up again this week too.
I mean, I think, Brendan, what you were saying though kind of hits the crux of the decision point, which is around who has to make a change. Is it the client or the registry to support this? I think the standpoint of doing it all on the client side sounds easier from the perspective of I can just write I can just kind of hack around the existing spec and get it to work as is with registries. But that kind of cuts out the opportunity for registries to potentially optimize there, or to really think about like if we have extremely large artifacts, whether or not or like how registries might want to handle those. So I don't I want to figure out a solution that kind of obviously works best for both sides. And I like to start with kind of what we consider an ideal situation and see what the blockers are from both sides. Like I really do think that the DM Verity is an ideal solution from a client side. How do we get that to work with a registry side is a little bit more complicated. We could just throw large blocks up there. Maybe we just support Blake 3 and add annotations for it. But yeah, that's kind of my perspective on it. I would like to get, I don't know, Jeff, how much time you've spent thinking about this, but you have a lot of opinions on stuff that has a registry effect.
I do.
Like, what's your thought on these? Like, I mean, what do we talk about? Storing 400 gigabyte AI models potentially in registries, or that's kind of the scope we're trying to discuss. I think does that sound accurate? Syed, Brandon.
Yes. I mean, yeah.
I mean,
We
yeah, reading through the proposal, or at least the thing that's linked, I am kind of curious. My fear with kind of doing a new artifact type kind of puts a lot of pressure on a lot of people to implement something, and that always is just going to slow down implementation. Versus like a proposal of just chunking it within the manifest. I guess my question there of if we had say we did like a chunked media type where we take 100 gigabyte model and we upload it in 5 gigabyte chunks, does the registry actually need to validate the hash of the entire object, or do we care? Because like from a register standpoint, the only things it really cares about in like the Merkle tree is that like the data itself is valid and that the references within the manifest to the layers are valid. It doesn't necessarily care about the entire assembled object, I guess.
Yeah, I think in that case, the registry wouldn't care because the client would be responsible for pulling down and verifying each of the 5 gigabyte chunks. In terms of like, the assumption is that the manifest hash at that point would represent the full set of correct chunks in the correct order.
So I haven't looked at the DM Verity implementations. Is there the ability in there to accept multiple ranges on the upload and compute the ranges as they're coming in out of order.
So with DM Verity, you basically have a well, first up, DM Verity is not a distribution format. It wasn't really designed for that. It's more of like something. It's a format that the kernel uses for verifying. So that's why I said it's kind of basing it off like the 4K hash or the 4K page size, because that's generally what like the block sizes end up being in a DM Verity case. The design of it though is for DM Verity, you have a single hash that represents the root hash, and then you have a hash of every single block just laid out sequentially. So you would have the ratio would be, if you're using SHA-256, that's 256 bytes for every 4K page. So like the ratio in that case is like, if you're using 4K page, it's like oh my gosh, my math, 1/16 or something the size roughly. So if you have a 16 gigabyte file, you have a 1 gigabyte of Verity data, essentially, that would be tagged along with it. And so on. You can increase the size, but then like if you want to directly use that by the kernel, then it's going to be less efficient. But yeah, I think you understand that part.
Yeah.
So
Yeah, the verification makes sense. It's the generation. Are there tools that allow you to generate that whole hash tree out of order without knowing the size of the blob in advance and all that stuff?
I don't. Well, you can generate it without knowing the size. Out of order, it's just a matter of memory. You can calculate it in whatever order you want, but then you have to hold enough memory to do the calculation. So the way it works is for each page size, it gets rolled up into levels so that you're not using the max amount of memory you need to use is logarithmic based on the page size as well. So if you're doing it out of order, then you could potentially have to store up to the whole size of the final output, which would be 1/16 of, or whatever ratio you have.
So I think as long as you're doing chunks, you're not doing like individual bytes, but you have somebody uploading a stream and they just upload a 50K chunk of whatever the file is, or a 1 meg chunk, you would get all of those blocks and get all the hashes for all those blocks filled out. And so you just have the beginning. If it's like if you didn't begin at the beginning of a chunk, and wherever you ended, if you didn't end at the end of a chunk, everything else you'd roll up into the hash at that point.
Yeah. So I guess,
Which,
yeah, the main thing about if you're using something like DM Verity, you always verify the Verity hash first. So you need the full list of hashes to get the root hash. And likewise, if you were to upload, say, a Verity hash to a registry, it'd be a much different type of calculation. That's why I said it wouldn't really fit into our existing distribution API almost, because you would have to upload you'd have to upload the Verity information and then link whatever you're uploading to that Verity information. But really at that point, you don't have much you need to verify, because you would you would always upload within a specific chunk range. So there would be no, if you had something that was Verity based, you would link something to that Verity hash and say like, hey, I'm uploading this chunk for this hash, and you could just check them based on the information you have. So there wouldn't be any like you could have a file with a bunch of holes in it, like it wouldn't matter. You wouldn't necessarily need to even have all the information. Like you could have a registry that only serves a subset of those chunks, or you could even immediately start serving that information and just return like hey, I have the Verity information, that's enough to start serving that object. And then if somebody asks for a block that doesn't exist, you could potentially run into a case where the block doesn't exist. So it's a kind of a different distribution model that it would that it could employ. And I feel like it doesn't
Yeah.
really fit into the distribution spec as we have it today.
So it wouldn't be a hash algorithm necessarily, but it might make sense to have it as a media type of what you're distributing. And then the hash algorithm could just point directly into the top of the media type and just say, hey, our hash for this thing is whatever the DM Verity hash comes out as.
Yeah. Yeah, exactly. Yeah, the DM Verity hash would be something. Yeah, it'd be probably a different media type, different meaning of the hash. But then at that point, what does it really mean to use the registry as distribution for the individual blocks? It's more like acting like a cache. Well, it's almost acting like a page cache, because that's essentially how it would end up getting accessed.
So I'm thinking, looking through my description site, I pretty much described DM Verity in the GitHub issue.
Okay. Oh, that's good news.
I knew I wasn't being innovative in that. I'm just coming up with something off the top of my head that I'm sure 20 people have already done before me.
Here's the difference. I think, like, when you say in your approach, Brandon, the blob itself that is uploaded is stored as is a full blob. So imagine you're storing this in S3. You have, let's say, a 400 gig big file. Whereas in Derek's approach with DM Verity, the big blob is not stored as one big chunk of a blob, but it's stored as multiple smaller, whatever chunk size we have, right?
I don't know if DM Verity chunks it, does it?
Well, DM Verity itself doesn't chunk; it just defines a chunk.
Yeah.
It just defines a hash
Yeah.
for a chunk, and you can store it or not store it wherever you want.
Yeah, it's a block level file system.
Yeah, I mean, it's intended for accessing a block level file system. That's why I said it's mostly about page caches, because you're usually it's verifying a page that you're pulling out of a block.
Right, and the pages are not guaranteed to be contiguous. That like the pages are anywhere in the block storage.
The reads are not guaranteed to be continuous, but you would have a full device from end to end.
Sorry, what was that?
If you had this on a block device, the full block device is going to exist, but your reads may be out of order or going into individual blocks.
Correct. Yeah.
Because think about it as a file system rather than as a distribution.
Yeah. So now the question, like, I think we're kind of converging on the same ideas everywhere. But one question for me, it's still unclear, is at the end, are we storing the blob that's uploaded as a single full blob, or do we store it as multiple chunks of like SHA-256 and then have them linked? I prefer the second approach just because of the way distribution of smaller chunks is much easier for a registry. But I don't know what other people's opinion is.
I mean, I guess the question is, do we want to teach the registry how to chunk, or do we want to teach the client how to chunk? And that's what it comes down to.
Right. Yeah, that's cool.
Clients are usually easier.
Clients are easier to teach with existing registries, but if you teach the registry to chunk, I think you still have to teach the client to chunk. It's, do we want the extra value of changing the registry too, in addition to changing the client?
I guess it's not clear to me, if you teach the client to chunk, what extra benefit is there for the registry at that point? Because it kind of seems like you got most all of the benefit then.
Yeah, I think the only benefit is, so in the approach which you suggested, where just put everything in the manifest itself with annotations versus having some kind of a DM Verities or similar kind of a format, is that the way you reference the blob changes. So or the way you reference an artifact changes. So in the first approach, the reference to an artifact would be a single SHA-256. Whereas in this approach, there's no clear reference to that specific blob. You gotta, the reference to the blob is a list of layers, essentially, or list of SHAs. So we're kind of, it's the same thing, but in the first case, it's more formal. I guess it's more, if it's in the spec, it's how everyone would use it instead of like one-offs.
So yeah, I would say the trade-off is in complexity. You greatly increase the size of the manifest by basically putting the chunks in the manifest. And I mean, just what if we're talking about 5 GB chunks, which are still difficult to upload to registries, and if you have a 400 GB file, and yeah, that's a lot of chunks to succeed. And I think today, even uploading a 5 GB continuous chunk to the registry and trying to make that succeed, what we talked about 80 times over, in order for the upload to succeed, is still unlikely. Or it's still going to be a lesson in patience to get that to actually succeed. I guess the other possibility there is something more akin to the URLs field, non-distributable artifacts, that we had before, where we could potentially offload the large bits to another URL or to another endpoint entirely within the registry for dealing with those like large artifacts.
So I want to react to the first part though. Said that if we put all this in the manifest, it's just going to dramatically bloat the manifest. If we had this in the manifest and said each of these is a chunk, and we assume each descriptor is what, like 1 kilobyte at most, you know, 256, however many that is in hex and whatnot. We don't put that much in JSON. If you did a 400 gigabyte blob that got chunked across 2 GB chunks, that would be 200 entries in, or 200 entries in the manifest. You're talking about 200 kilobytes, not even up to half a meg yet for the manifest. So I'm not too paranoid about that threshold yet for this scenario. As Jeff mentions, he's seen people with a lot more than that.
Yeah, sorry. Yeah, Jeff's comment there was a little distracting. Was that a legitimate case? Like somebody actually tried to use it, or it's just a really horrible bug?
It was, I believe that one was someone hacking a file system on top of an artifact. So, I mean, not like an actual image, but like there are use cases out there where people are putting enormous numbers of layers inside a manifest, and like there's no spec limit on there.
Was it TAnon?
It was actually not, and it was not you either. So I mean, that's generally the two culprits. So.
Oh boy. Yeah, we do have a limit in there. We say that registries must support what, 4 megs for a manifest. So if they have more than 4 megs for the manifest, you're allowed to say bye.
I don't
reject it.
I thought the 4 meg limit was for the config. I don't think the manifest has a limit.
No, it's for the manifest.
Manifests are limited to 4 gigabytes.
Megabytes.
Megabytes, yeah, sorry.
Most registries don't like stick to that. I can upload, like I've uploaded multiple hundreds of megabytes of manifests.
Yeah, it's not that you can't, it's that the registry is allowed to say reject.
Docker Hub definitely rejects manifests that are even a single byte bigger than 4 megabytes. I've tested it recently.
And we're talking about the manifest JSON, not the layers. Not the blob sizes for the layers.
Yeah. Yeah, no, my arguments for the putting a separate entity for chunked blobs is not the size of the manifest, but the implementation. Like, let's say we put annotations and we do that. It basically opens up. Everyone has their own implementation of doing chunked uploads with their own annotations and whatnot. And there's no single way to validate a single blob. So for example, if I want to, a simple way to verify a blob would be to just verify the DM verity of that blob instead of pulling the whole blob. Whereas in this case, I gotta pull the whole blob and verify it, if that makes sense.
Yeah. Yeah. I mean, I think having this, the solution could be somewhere in between that, where it might be useful to pull or to have a DM verity as like a first layer, and then you could stripe the data essentially across other blobs if you wanted. I mean, I guess the advantage of DM verity is that that is all you really need to make a block device available on the file system if you're doing a lazy approach. And as long as there's an algorithm for getting the individual chunks that you need, it doesn't really matter how it's chunked as long as there's an algorithm to get it. What is
Saeed.
Tianan doing? Oh man.
Sorry, I missed that.
Tianan's trying to test the boundaries of everything.
I was going to ask Saeed on the last comment there. If you start to chunk everything up, what's your concern with validation? Because you would have the digest. If you did this all client side, you would have the digest of every layer. You have to send those up individually. So every chunk would have its digest.
It's more about defining what the whole object is. But as I said, it's as long as you have a chunking algorithm, you know, you can, it doesn't really matter what that algorithm is.
But it's completely ignoring a separate chunking algorithm or changing digest algorithms, anything like that. Going just what we have today, we've got a SHA-256 of each chunk because you have to have that to push that blob. And so you would individually verify each chunk as you pushed it and pulled it.
Yes. No, I what's the I don't think we're in disagreement about that.
So I'm trying to understand the concern of, okay, we don't have a way to verify what, because DM Verity doesn't say
No,
we're
I didn't say we
verifying
don't
the
have a way
entire
to
thing.
verify it. I'm just saying
It
with
wasn't you,
the-
Saeed was throwing up a concern on that one.
oh, okay. I'll let Saeed respond.
Saeed, did you get pulled away?
Sorry. Sorry, what was your concern again? I'm sorry, I zoned out.
No worries. You were saying that if we didn't have something like DM Verity and we were pushing this chunk to doing the verification client side, that there would be a concern of trying to verify the content. And I'm trying to understand that a little better, because if you did this client side, you would have 200 layers you're going through verifying individually. Each layer is
Yes.
going to have its own SHA-256 blob digest because it's going to be pushed up as a regular blob to
Yes.
the registry. So if you're verifying each blob individually, what's the verification concern you have of?
Oh, no. I mean, with something like DM Verity, verification when pulling is going to be much easier because I can just pull the DM Verity info, and then I can verify the hash of that, and then I know that all the other hashes are good.
So when you pull the manifest has a hash.
Okay, yeah, that's
Knowing the manifest hash, you know
I
that
think the
rest of
point
content
is
good.
okay. So if we're trying to look at it from the client side perspective, like that hash is validation of that whole block, and say they're in 5 GB chunks. If you have a normal chunking, or if you have no other chunking algorithm like DMVerity on top of it, every time you want to access one of those chunks, you have to pull down that full 5 gigs. Whereas if you just had the DMVerity information, that hash is just relevant from the content addressability aspect of it. You know where to get it from the registry, but you don't actually have to pull down that full 5 GB if you had the DMVerity information. But you can like you can figure out which chunk it is based off however the registry, or however the manifest is basically laying out, here is where the bytes are in the registry. Like this section of it is going to be under this hash, and you can go grab it. But even if they're 5 GB, like downloading a 5 GB file to access a single aspect of it might not be what the client actually wants to do there.
With these 400 GB artifacts people are trying to push and pull the registry, if they pull it back down, do they want just a partial, or do they need the full thing to run the model?
Yeah, that's depends on the use case. I mean, you could for the models, you might always need the full thing. I'm not actually sure of all that case, but I assume at some point, considering if you have a 400 GB model, you have a lot of VRAM that you need to populate. So you probably need that data to do that.
I think another point that was raised earlier was that most sometimes like all these big files have very similar, or if not the same, initial chunks, or initial, like let's say the 10% of the initial file is the same or whatever. Distributing that via this DMVerity approach is much easier, because I can now only, like, the client needs to only download what has changed, similar to what layers do.
But if you chunked it client side, you'd have that digest already pulled.
Right.
And same on the upload, you would have already pushed that 2 GB before, or see that it's already there, and the registry would say, you don't need to ship that layer a second time. Somehow I ended up talking up the beauty of Merkle trees and tags.
Yeah, I feel like Brendan, you switched from the beginning of this to like halfway through from you like this approach, or you didn't like this approach, to you like this approach.
So I'm not too firm on the direction this goes down, but I just want to make sure if we make the registry more complicated and make a non-backward compatible change, that it's worth it. And I can throw out a solution there that I don't think requires us changing anything on the registry side, works today, just put some work on the client. But you're going to have to write that code in the client no matter what. It's either going to be specific to these AI models, and they just probably write a library and everybody shares the same library for redoing these chunk things. Or you end up putting it into, you know, into the libraries themselves, into the registry, into the API. And I want to make sure there's value in doing that before we go that path.
Well, yeah, and I guess when I say when I suggest the DMVerity, it's not necessarily one or the other. I think either way we want DMVerity for various reasons. Because I'll just say the interface in my head for like what I would want to implement on the Containerd side is, we have the content store today, which is essentially mirroring the sequential hash approach. I would love to have like block store that's could work with the content store or could work as an alternative to the content store, but essentially instead of just providing sequential, just basically it's all sequential, like a hash that's calculated sequentially and a byte stream that's sequentially, something that's accessed, has random access and is defined by essentially a DM Verity hash. Like you'd populate it instead of like you'd create it by giving it a DM Verity hash or giving it the DM Verity data, and then that would make the block available, and then connect that with whatever system for accessing the data, which could be the content store, could be the registry, could just be a cache on disk. So like to me, that's the interface that I'm thinking in my head that I love in Containerd, because if we had something like that, you can make a block device available, you can make a file available to the container or to the AI runtime, whatever you want. So that's kind of the way I'm thinking about it, but they're kind of two separate. They're kind of two separate solutions. Like one is like, how do we make it available to the operating system? And I think that's where DM Verity makes it really nice. And how do we distribute it? And that's where DM Verity is not so nice, because registry would be like, this isn't how I look at data. So I think if we have some mix in between that, I like chunking up like having partial pieces as content and manifest, I think is fine, as long as we figure out, like, I just think we should have a holistic implementation of it and proposal for it before we like try and just solve like partial issues there, if that makes sense.
So the registry doesn't work with it like that today, because the algorithms we have on the registry are like SHA-256. It's a full stream of the full content. If you change to a different hash algorithm and said, we're going to have a hash algorithm for DM Verity, and it's just going to look in there and look at that top little master, layer in there, pull out that top level hash and just report that. You don't have to verify all the content, because this is, a content that contains a hash of a hash of a hash.
Yeah, I mean, that's kind of one thing I was thinking is when you upload a file, what if you, because like DM Verity information, for example, like if you have an ArrowFS file, you can put the DM Verity in the same block device, and so like you could basically append the DM Verity to the end of a file, and you basically have to give it two information, like what's the offset for the DM Verity and what's the root hash, and the page size, if there's different page sizes. But basically with that information, you can upload that first, and then everything else after that can be parallel. It can be lazily done. It could be not done at all. It could be point to somewhere completely different. Like, but yeah, that the amount of like complexity that would leave to the registry in terms of like having wholly blob seems kind of complicated. Whereas to the client, I think it makes a lot of sense for the client to be able to handle those like incomplete wholly objects. But yeah.
Yeah, so the question is, where do you put that metadata? Is the metadata in the artifact itself that you're shipping? You could have a DM Verity hash type that just says, look at the first top entry in there. But if you do that, you're modifying that blob to no longer be whatever the AI model is. It's now a DM Verity file. Or do you externalize all that metadata?
I mean, I think there's two, because you could have a dedicated DM Verity file, and that could be like the first object, and then everything after it could just be the partial content that's associated with it. Or like in the ArrowFS case, like, well, you might not, hopefully for a normal container image, even if you're using ArrowFS, the file systems should be much less than 5 gigs ideally for like just a normal workload. You could just deliver it all in one layer. And you can just tag it on the end, like with a plus ArrowFS, and use annotations or something.
I do think we solved this with trying to externalize the hash data, ship it separately, and just do one massive blob, though. We're going to recreate all the problems we're trying to solve with going through CDNs, with interrupted transmissions. You're going to have registries rejecting a 50 gig file because at layer 49, if we had chunked it up, they dropped the connection.
Yeah, I mean, I don't think it's unreasonable for us to put, if we add the chunking, to put in specific guidance to say, as a registry, you may reject blobs larger than this. Like, we don't have that today, but the reality is there are users pushing up 20 gig, maybe more files, but like at least the ones I've seen users come back and have the audacity to complain about it was like a 20 gig file. I think if people are doing larger, maybe are more like wouldn't even bother complaining about it. But yeah, I've seen folks coming in with that 10 to 20 gig range, be like, hey, it's not, you know, like I can't upload it. It's takes too long, and then the connection times out, blah, 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 blah. But at some point you have to draw a line and say, hey, you know what? Like, oh, like the way we're calculating the hash, you know, like the amount of time it's going to take, how long a registry has to hold on to this object, this partial object to compute this hash. It's not reasonable to accept files over this size, or to that it's reasonable for a registry to reject files over that size, I guess.
So now you're saying the registry would require us to do client-side chunking?
If we add it to the spec, we could say that the registry can reject blobs over this size and request the client to do client-side chunking, if that's the approach we want to take. I mean, if we have a new hash algorithm, maybe it's not as important, but I mean, if we're saying this is the best way to do it from our own specification perspective, then we should have clear guidance around it.
Yeah, I just feel like a new hash algorithm doesn't solve the very large blob problem.
Yeah, I think I agree with that as well. Like, I think for like a 5 gigabyte file, it could still be useful to have like the Blake 3 support, just because like that's still a lot of data, and it's, you know, like to hold on to the hash state for that is kind of a pain. Like if you're uploading 400 gigabytes and, you know, doing it and parallelizing it into 5 gig chunks, it makes sense, but that's for a very specific use case. I think more likely users are uploading between 1 to 5 gigs of data, and would like that to be parallelizable on its own. But yeah, so if Blake gave us the ability to parallelize those uploads, then that would be a win. But I don't think I agree. I think I agree with you that that doesn't give justification for just making the blob size unlimited.
Yeah, I feel like we're still going to have problems with CDNs. We're still going to have problems with timeouts on uploads. And so it would end up going to either some new API that the client sends it up as some kind of complete chunk that the registry recognizes this chunk is now complete and can deduplicate with other chunks that it sees and whatnot. Or you have to go client side.
Are there specific CDNs that, or is it all CDNs that have trouble with large files and chunking those up themselves? Or this is an area I'm too familiar with, but it sounds like that's a
I think a bunch of them have size limits.
Yeah. The problem comes when some of the so the idea of a CDN is that they have point of presences in pretty much all regions around the world. And not all regions are equal. Some of them are extremely restricted in terms of bandwidth. And these guys, they don't want to push large files in there because then it's going to affect the capacity they have there. So they generally restrict the amount of data you can push to those regions.
Gotcha. But what I'm saying is they don't do chunking underneath their own storage. Like if I have a 1 terabyte file that I want to serve through a CDN, like they're not just going to serve a subset of that or cache a subset of that based on what was requested or what?
Maybe I don't know how they operate internally, but what I do know is that when you exceed a certain amount of size, then they just forward that request or they proxy that request through the origin. So they will just raise their hands and say, well, like we're not caching it. And then you end up paying ridiculous fees for egress traffic.
Yeah, I understand that. I guess my point is like either way, if you need all 400 or all 1 terabyte of a file, it's going to go through the CDN. The question is like, is the CDN smart enough to chunk or like store it in chunks if you don't access all of it, or is that a real optimization to for us to do that chunking on the client side, or to have the actual file names be chunked or limited?
I'm just digging through the Cloudflare one right now, and they're saying 0.5 gig for the free plan of 5 gig for enterprise. That's on the response. And so if someone says, do a get on this blob, it would say, hey, you requested a blob that is 6 gigs. This doesn't go through me. This gets passed upstream.
Gotcha. So even if you just requested a content range that was much smaller than that.
That I don't know.
Because I believe we always are almost.
I don't know if they're going to cache a range. I think they're going to cache the entire content and serve a range out of it.
So, okay, you have a large file and I request a random range from a CDN. Does it pull in all of that? Like, what does it egress out of your backend? Does it egress the whole thing, or does it egress that range? I guess that's the open question. But
yeah, it's CDN dependent. For Cloudflare, I can tell that they need a full file, and then they'll serve the range.
Okay.
And you can modify that behavior, like you can add more workers logic on top of it, but that's the default behavior.
Gotcha. I mean, I guess most of the time, at least for what we have, we use ranges, but we start at the beginning and then we go to the end of the ranges. So like, it wouldn't really matter. We wouldn't really have that case anyways until we get to like lazy loading of stuff, and then
so our API has support for ranges, and some people are using it, the lazy loading being a good example. But I feel like the vast 99.999% of the requests are just give me the entire layer.
yes, but even give me the entire layer, do we chunk it up on the well, I guess it depends on the client.
I would say not at the higher level client making the request side, but it may be something lower level underneath that request, like the Go library to an HP underneath the request.
I don't think Go would, but I'm not sure if we just added something in containerd to add, or about to add the parallel polling that would basically chunk everything up and try to access stuff in parallel. But I don't think that would change the case where where you're not using parallelism. You just want to stream the whole thing. Okay. Yeah, I mean that's not super relevant for here. I was just curious if from a CDN perspective, my hope is, yeah, these large models, if the whole model needs to be loaded, no matter what, you're paying the CDN costs to go through. I mean, it sounds like you could work around these CDN limits where the CDN is just going to be like, hey, I'm not even touching that file. But
And just like that, we ran through an hour. Sorry, Tianan, you did not get your hour back today.
Tianan could have left at any point he wanted. No one was holding him hostage, just for the record.
You know he can't leave. He can't do it. All right, Mike, good to see your face. And I think with that, we're a wrap for the week.
It was an interesting discussion. I'm just listening. I've been through this windowing and congestion space many times in the past. It's not easy, and there is no one real answer. You know, it's what protocol do you support? Okay, do the client and the server both support that protocol for doing congestion management and caching of the CDN? You end up saying yes and support as many as you can, and just make it pluggable and extensible, and you'll usually be okay. Don't pick a default because it won't work. Not on
Yeah.
both the client and the server. Yeah.
All right, I'll see y'all later.
See you guys.
No, bye.
Thanks all. Have a great one.
Take care.